Okay, Intro to PLC and Advanced PLC. I've got the program up that's got the different ladders in it. Now, I wrote this on a Compact Logix, and so I am the older Compact Logix, so I am on RS Logix 5000, which is version 20.04, I think it is. Okay, and so for Allen Bradley, your main routine has to be a ladder. And what I'm doing in my main routine is I am jumping to the other programming languages. So when you go to set up a routine and you say new routine, you can change the type of routine. So you can make it a ladder, sequential function diagram, function block diagram, or structured text, depending on what you want to make. And so what I did in this program is I took a fairly simple concept, programming concept, and I used it in the different forms, and I wanted to show that to you. I've also printed it out as a PDF, so you can get a printout of this, and I will put that in both PLC classes too. And so what I'm going to show you on the screen, I'll quickly run through at the end and show it to you on the printout. Let's see. I want to go back to that. There we go. So I'm in my main routine. I'm jumping to all my subroutines, and these are there's no logic. So it's going to jump to these routines every time. There is a comment in one of my programs that if your subroutine has a condition to jump to, in other words, I've got logic out here that something won't work right. And hopefully I'll talk about that here in a minute. So function block diagram, let's go to the ladder because that's what you're most familiar with seeing. So what I have done is ladder logic. I've got two inputs ANDed together going to an output, and then I've got two inputs ORed, the same two inputs going to an output. And that's what that would look like in ladder logic. Now, as you go into these different forms in the advanced class, I would start simple, get it working. There's also a book on how to program in the different forms, and that's what I used as my reference. And there's a few things in there they won't tell you that they assume you know. So that was interesting, but I figured it out. Okay, so this is it in ladder. And what I did is I used the same inputs in all these other subroutines, but I used different outputs. And that way I could tell by pushing the same two buttons if my outputs were on and if they worked the same using the different ones. So it was a pretty good test. And you can duplicate this program. You might be able to upgrade it to Studio 5000. I'm not sure. One of the things you got to know about Allen Bradley is it's generally not backward compatible. So that forces people to buy their newer hardware and their newer software and update, which is more money in their pocket. So unfortunately, that's the way it is in the Allen Bradley world. But this is going to look close enough to Studio 5000. It should work. I don't know if you can directly do it, but you should be able to. This should give you a good basis to actually do it. Okay. So my main routine is my main routine, and it's got to be in ladder. In Allen Bradley, it has to be a ladder, but all your subroutines can be in whatever form you choose. So I did it now as a function block diagram, and what you notice is in my first rung, I'm ANDing the two inputs, which is what I'm doing here. I'm ANDing. And I get output 3 and output 4. So I used output 1 and 2, and now I'm using 3 and 4, and here's the OR. And so this is what the ladder logic would look like as a function block diagram. Okay, I'm going to show this one last. Statement list. So this is what it looks like in code. Now, anything with the double dash marks is a comment that you put in your code. And so I put some comments in here for me. End all statements with a colon. So that's my reminder, because if I get in here writing and the end of my statements that matter don't have a semicolon, then what I found is it doesn't work. So basically, this start stop logic is input 1 and input 2, then output 7. And then I end if. And so if these are not true, then I think it jumps to the next one. Oh, then output 7. Okay, and then it's ending that if statement. And now if I have input 1 and 2, output 8. So I'm turning on 7 and 8 if I got both inputs. And then if those are not true, if I don't have both inputs on, then I input 1 or 2, then I can turn on output 8. And I'm physically having to write output 7 to 0. So I'm writing it to a 1, and this is how I write it. I had to figure out that part of the code. To a 1, and this is how I write it to a 0. And it's got to be in that form. It's just like any other C, C++, Arduino. Once you get the form down, you can do this. And then if not input 1, not input 2, in other words, they're both off, then I've got to write both my outputs to 0. And that ends my logic. Okay. So ladder, function block diagram, and statement list. Now, this is 7 and 8. So now I go back to my sequential flow chart. A sequential flow chart is not good for something that real time can be changing. Now, if you've got something that you're going to do this step, and then this next step, and then this next step, this would be perfect. But as far as having, okay, I've got 2 buttons and I'm either pushing them or I'm not, and I want different lights on. In a sequential flow chart, you've got to actually have what we call feedback and loop around, which took me a while to do. The other thing about it is it didn't do it where I wanted it to. The program did it where it wanted it. So for instance, when I get to the bottom of this one and I tell it to go back, it's actually jumping back up through itself. So you can't see the little line that goes around and comes in. So you don't really know which of these is all connected. But a little bit about sequential flow charts. If you set them up well, then they'd be fine for a sequence of events. So I had to do an initial. So anytime I call the subroutine, it does an initial, and this would be not every time through the scan. This would be the first time through the scan. It sets up my initial. Okay. So then I've got 3 conditions. I can have both inputs on as reference. So I can have both push buttons on. And so this is the conditional. Okay, so let's go through the program. I initialize it, and it goes to step 0 somehow. Oh, initialize. Okay, that's the other part of this. You've got a block that does something, you've got a conditional, and then you've got to go to a block that does something. And so to get from this initial over to this step, I think I'm going this way. Okay. If you don't put the step and then the condition or the transition statement in order, so block, transition, it won't work. It won't like it. So you've got to think in terms of that. And that took me a while to figure out. So my transition, I just do an initial. It initializes the subroutine. It goes around here to step. The only thing happening in this step is I'm giving it a 2 millisecond delay every cycle. So it's looking for the buttons to change. In this step, it just has a little bit of a delay. So if it sees the buttons, it acts on it. Okay. So then I have 3 different conditions. I can have both inputs off. I can have one input on, either 7 or 8, or I can have both inputs on. And if both inputs on, then I want to turn on both outputs, which are 5 and 6. If one input is on, I want to turn on output 6, but not 5. And that has to do with my logic. And if both inputs are off, I want to turn both outputs off. So once it does the action, then I've got this transition that tells me both my off outputs are off. Now I go back, and so it's basically going back up and sitting on this step for 2 milliseconds. The nice thing about sequential flowchart, and if I turn on one, it tells me it's done, and then it goes on. So as soon as this action happens, it sets a done bit, which is what I'm using to tell me that this happened and move on to the next step. And so that's pretty interesting. It's not really good for push buttons. It's would be better for a sequence of events. The nice thing about this is the highlighted part here is where it happened to be when I stopped the program. So this is where it basically waits. It waits for an input. And so if I did have a sequence where I went from one thing to another, and I didn't have all this feedback looping I've got going on, then it would stop and you would easily be able to see as a troubleshooter what step it's in. So like in your drum program, if you want certain outputs in that step, you can do that. So you can turn on both, you can turn on one, you can turn both of them off. So I could have a step where I initialize, I turn on one light, or I have both lights off, I turn on one, I turn on both, I turn them both off, and I can have that step. And I can have a transition. And if the program gets hung up, then you know what step it got hung up in if you're online with it. So this one's better, this one is better for a sequence rather than something with it's looping around where you constantly want to be looking. Stopping, if I stop it, resetting to initial and next rung of main. And sometimes you have to create tags. I don't remember what that comment was for because I did it. There you go. Here's my JSRs aren't unconditional. One input on either, then turn on output 6, references back to ladder. This won't work unless all JSRs are unconditional. So I had to make my JSRs unconditional to turn it on and off. And that way it'll come back around and back in. If you have a conditional on there, then I think it can get stuck in a sequential program. Anyway, again, start simple. Start real simple. Do something. You can take this model. There is a book on how to program in the different ways. And so I will put this program, once I get back to it, I will put this program out there for those of you with access to Logix 5000 or Studio 5000. You can see if it'll open and upgrade. If you can't, then I will also put the printout on here. So basically it's showing you my page, my initial page on the left side, and what all I have module wise, what my IO configuration is, and now every tag that I wrote, I got my tag listing, and it's one of the things that comes out when you print out a report. And where I got this report is I did file and I did a generate report, and I left the options all default. So I knew I was getting my routine listing and my tag listing maybe, and then I printed it to a PDF. Okay. So that's how I got this. So I've got my tag listing in my controller tags. It tells you where the tag is. And again, this is something I haven't done since, well, early last spring. I don't know when I did this. I did it for the last Intro to PLC class, so it probably would have been in February. And haven't been back to it since. So do something in February and then come back in September and see if you can remember everything you did. The nice thing is it's here, and in my mind I know in general that it will work and that I got it to work. So I've got all my tag listings, whether they're Boolean or whatever, and I'm just doing a simple program. I mean, really simple. I just did it 4 different ways. If I scroll down far enough, I get to the ladders. Did I go too far? Now, interestingly, okay, that's the end of the tag listing. And so here's my first printout, my function block diagram, which is what I showed you on the screen. There's my ladder diagram. Don't ask me why it put the main as the third one. I don't know. There's my main ladder. There is my sequential flowchart ladder. And this should come out as 8.5 by 11. There's my structured text. So this is all something that you can print out. And I probably made some errors, and I probably have some stuff in here that I don't need. This is telling me what my parts are on my PLC and how everything's configured. Some of what we configured, revision number, what slot things are in. So it's basically giving me a list of my hardware, and that's what I've got on the compact Logix. So that's not going to change on you. And it actually gave me a reference. Did it give me a table of contents? It did. It did give me a table of contents and tell me where everything was. So that's page I, which should be first in my mind. Anyway, I wanted to make a video of that, and I will put the PDF file in it so anybody can look at this program, and I will put the program in it. So Logix 5000, you'll have a copy of it if you want to go in and look at it, make modifications, whatever you want. And I thank you for watching.